Hi General Math students. We're going to look at an example of a business with a fleet of vehicles. We're going to examine how the number of vehicles in this fleet changes from one year to the next. We're going to do that using a difference equation. So, we're asked in part A to set up a difference equation to model the number of cars owned by the business each year. So let's look at the important information here. They're going to be retiring 30% of the vehicles each year, and they're going to purchase 20 new cars each year. So that's the important stuff for our difference equation to begin with. Now let's look at this first bit with the 30% of vehicles being retired. So of course 30%, now if we've got a decrease of 30% each year, that means we need to subtract that percentage decrease from 100. So we're actually going to be working with 70% and thinking that rather than thinking that we're losing 30% of vehicles each year, the business is retaining 70% of its vehicles. So if we convert that to a decimal for the purposes of this difference equation, that means our decimal is 0.7 for our difference equation. Okay, so that means to get from one term to the next, so we take the previous term and we multiply that by 0.7, and then we add 20 to reflect the fact that there are 20 new cars each year. Now, the first term of the sequence, T1, is equal to 30 vehicles. That's the number of vehicles that is in the fleet at the beginning. So we'll put T1 equals 30. So that means in year one, there are 30 vehicles. So in the next question, we're asked to generate the first 6 terms of the sequence. Just going to do this on a scientific calculator to begin with. In part C, we're actually going to generate this sequence up to 15 years. So that might be a different way to do that, part B, but this is kind of a pretty quick way. So we'll just do this just to start off with. So we're going to take the initial number, which is 30, and we multiply that by 0.7. Then we add 20. So that means we have 41 vehicles in the second year. So I'll write that down. So first year is 30, and then next year is 41. Okay, now I'm just going to immediately press multiply, and the calculator carries over that number 41 from the previous answer. I multiply that by 0.7 and add 20, and I've got 48.7 in the next year. And I'm just going to keep doing that until we get to the 6th term. So if you were going to give a particular number of cars in a fleet for any particular year, you'd round these numbers to the nearest whole number. But while you're generating the sequence, you just leave them as decimals. Okay, so that's 1, 2, 3, 4, 5. 1 to go. And 60.5 at the end. Okay, so that's fine there. Pardon me. So, like I said, we'll check this right away by actually preparing a graph on the calculator and making a sketch of it. So that's going to require us to get the TI fired up. So switch that on. And we're going to start by going into the lists and spreadsheet. So this green button. Ooh, if you missed that, this one here. Okay, so I'm going to go into that one. Okay, now I'm going to go ahead and put some headings here. So we've got years in column 1 and cars in column 2. You don't need to necessarily use the full word there. You could just use Y and C or something that you'll remember. Okay, so I'm going to start with 1 year, 2, 3, and go all the way up to 15. That's how many they want from us. Okay, all right, so go ahead and enter all those. Okay, so if you need a bit of time to catch up, just pause the video. So I'm going to go now and enter the first term of the sequence here is 30. All right. Now what I'm going to do is generate the rest of the terms using a formula in the spreadsheet which matches the difference equation. So we're going to start by pushing equals. That's how we start a formula. So this cell is equal to 0.7 times, now we're going to use that, we're going to multiply by that first term. We're going to use that first term to generate the next term in the sequence. Now this term actually sits at cell B1. See that? B1. So I'm going to tap B1 and then add the 20. So see how it looks like the difference equation there? Okay, if I enter that, we get 41, which matches what we got before. Now, rather than typing that formula into every cell, let's just go back to that one where we entered the formula, and we're going to fill it down. So we go Menu, Data, and Fill. Okay, now nothing seems to happen, but the calculator is ready for us to fill down. So if you start pushing down, we can go all the way down to 15. It might take a little bit of practice to get that, but see if you can make it work. And I'm going to push enter now, and it fills in all the cells for us. Okay, so that's very nice. Now, oops, I've just lost him there. I'll try and find him again. Okay, so you can see that that matches what we got before on the other calculator. Now, they've asked us to do a sketch of this graph. So we're going to go and look at the graph and see what it looks like on the calculator, and then just do a general sketch of that. So I'm going to go back out to the home, and I'm going to go to the pink button now. This one here. So that is the graphing. Okay, whoops. Okay, so I'm going to click down here and put years. And then I go up here and click, and I put cars. So that is the shape of the graph that we should get. So you can see these 15 data points. Right, so we're going to go and sketch this general sort of shape and just do 15 data points that follows that sort of a pattern curving up. Now we have a situation here. You can see that the numbers are tending towards, like they're in, it's 66 point something, right? And it's starting to flatten out. Now, in fact, this curve and the number of cars is never going to reach 67. It's going to asymptote towards a number below 67, right? So we'll add a feature to our graph for that later on, but it's what we call an asymptote. It's going to just start to increase by very small amounts, but it's never going to increase by enough to get to 67. So we'll examine that later on. For now, let's just go back and do our graph. So I'm going to do a few data points. There's number 1, 2, 3, 4, 5. Now, I'll look back at the graph, and you can see that about number 6 is where it starts to really flatten out. So I'll start to flatten this out now. Don't stress if it's not perfectly the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it really flattens out here. 13, 14, 15, and this is not a very good set of axes. We really need to extend on this a bit. I'm just going to extend that and put years down there as well to show the labels. Okay, now I'm going to label 2 of these data points. Remember, we need to do that for a sketch. So this first one was 1 and 30. You can label any 2 data points. I'll label the end one as well. 15 and 66.4. Okay, so there's that sketch. When they're saying showing its details, I suppose that we just really need to show those 2 data points and the shape, make sure our axes are labelled. But Also, like I mentioned before, we want to show this, what we're talking about, that business, what the number of cars is tending to in the long term. Okay, so we'll put that in a moment. Let's actually figure out how many cars will this business have in the long term. Well, we can see from the graph that it's tending, like I said, it's tending towards 67. It's never quite going to get there. Now, you can actually figure this out. What number is it tending to? There's a formula. This formula is in the book, right? And what it shows is the common difference divided by 1, take the common ratio. Now, that will, if you put the numbers in, that will tell you what the maximum value can possibly be. So here our common difference is 20 and our ratio is 0.7. So if I actually put that into the calculator, okay, we see that it's 66.666 recurring. So that's the biggest number that's possibly going to get to. It's going to flatten out and never quite reach 67. But the nearest whole number is 67. So we'll say that in the long term, that's how many cars there are. Now just keep in mind, you don't get this formula on the info sheet. So if you forget it in a test or exam situation, you're just going to need to look at the graph and see what sort of number it's tending to, and maybe, like right now, you'd be rounding down to 66 here, I know, so you might need to extend on that in your calculator. Back here at this part, you might need to go a bit further down and see what sort of maximum number it's getting to. That's the other way you can do that. Okay, so we'll say 67 cars in the long term. Okay, now, how would the difference equation change and graph change if instead the business began with 10 cars? Righto. So we'll switch to red on this one. Given that we've been through part A, which was similar to this, maybe you actually want to pause the video, so I'll give you that opportunity. You can pause the video and have a go at this question and then check my answer in a few moments. Okay, so this is what the difference equation would look like. Pretty much the first bit is exactly the same. It's just the first term that changes to 10. So it's only the that first term that changes. All right. So if you were, I suppose, writing a worded answer to that, you'd say, how would the difference equation change? It would only have a different first term. Okay, now let's actually go and have a go at graphing this and see what that looks like. So I'm going to go back to the original thing here. So you want to get back to this spreadsheet. I'm going to put 30 into this one. Okay. Actually, sorry, no, I'm not. I'm going to put 10. That's the first term now. 10 into that one. Okay, now I'm going to put a formula in for this one. So this equals, now it's pretty similar to before, 0.7 times, now rather than B1, we want to follow down from C1. So I'll click C1 plus 20. So push enter there. Okay, now we'll go back to that cell, menu, data, fill, and push down. Oop, just having a bit of trouble there, bear with me. Menu, data, fill, and push down. I'll go down to 15 years, push enter, and that's what we get. Now that's interesting. Let's go and look at the graph for this. I'm going to go back out. Actually, sorry, I've got to put a heading here first. I'm just going to call this one Cars 2. Okay. So we'll go back out and into the graph. And we've got, oops, hold on. Years versus cars. Okay, now what I want to do is have the new graph on the same graph as this one. So to do that, you've got to go Menu, Plot Properties, and we're going to add a y variable. That means we're going to have a second y variable on the y-axis. And I'm going to put cars2, and there it is, comes up against it. And we can see both on the same axes now. So very interesting to note that it starts down lower with only 10 cars, this fleet, but it asymptotes to the same value. Now, if we were to try this on the calculator, remember we only have the common difference, which is up the top, and the ratio in the formula to work out what the maximum value is. It doesn't matter how many cars are in this fleet to begin with at all. It'll still tend to the same maximum value. Isn't that interesting? Okay, so if they start with 10 cars, in the long term, they'll end up still with a maximum of 67 cars. Okay, so let's graph that on here. Okay, so I'm just going to sort of start down a bit lower and just have it kind of, I'll just look at where it catches up. It's at about, or sort of catches up pretty much towards the end. So we'll just kind of have these data points in underneath and then getting pretty close towards the end. I'll just label that first one as 1 and 10, and then, oops, just give this a moment to catch up. Bear with me, guys. It's just a little slow at the moment. Computer's got a lot to think about, so we'll have them sort of catch up, and pretty much the same by the end. 15 and 66.4 as well. Just check that one, see what it is actually. 66. It's actually 66.3 at the end, so I'll put that 66.3. So that very last one there is just slightly below. Okay, so we've looked at how we've written down the new difference equation. We've put the new graph. What happens in the long term? Still end up with 67 cars in fleet, which is very interesting. So this business could really save a lot of money by only buying 10 cars in the beginning rather than 30, and they'd, 15 years from now, they'd still have a car fleet of 67. It wouldn't make any difference. Okay, guys, thanks for watching. Go ahead and check the description for the video and try some questions which involve these types of situations.